Hey everybody, this is Alex Merced, developer advocate here at Dremio, and today we're going to be talking about Project Nessie and Lakehouse catalog versioning, which is an exciting topic because it's all about being able to manage data quality by being able to isolate work because you can track different versions of your data. Okay, now before we get into our featured presentation, I want to just present to you this QR code. If you want to download the slides, this will take you to a Google Docs folder with this presentation and many other presentations. And also to make sure that you're aware that the Subsurface Data Lakehouse Conference is right around the corner on May 2nd and 3rd. So you want to make sure you register. It's free. And not only is it free, when you register, you get a free copy of Apache Iceberg, the Definitive Guide. Not an early release copy, the final manuscript. Okay, and that'll be available when you register for Subsurface. And you can register for Subsurface by scanning this QR code. Okay, but as you may know, I'm Alex Merced, developer advocate here at Dremio, one of the co-authors of Apache Iceberg, the Definitive Guide, and the host of several podcasts like the ones you see here on the screen, which you can find Gnarly Data Waves, In the Grand Scheme of Things, Data Nation, Select Star from Data Lakes, hop on iTunes, Spotify, and subscribe to all of the above. But with that, let's just talk about the reason why we care about catalog versioning. It has a lot to do with being able to manage what's referred to as a data lakehouse. But to understand a data lakehouse, we need to understand where things came from. Because traditionally what we would do is we would store data in databases and data warehouses, which would abstract a lot of things from us. Okay, they just basically worked. And under the hood of a database and a data warehouse, they basically was code that would figure out how it would store the data, how to organize that data into individual tables, how to track multiple tables within a catalog, and how do you process queries? How do you parse an SQL statement, turn that into a query plan, and then execute that query plan? All of this would be abstracted away. You would just sign up for a data warehouse and be able to write SQL right away without understanding or needing to be aware that any of these things are being done. But the problem is, this generally works for structured data. So whether it is, row-based data like we generally see in databases or columnar data like you typically see in OLAP or data warehouse type systems, you also have this whole world of unstructured data. So, and then also generally you're not going to put every single bit of structured data in a database and a data warehouse because there's just so much of it. So that led to the advent of data lakes, where basically you have the storage. This would be like your object storage or a Hadoop cluster, and you would have compute. Okay, you would have tools like Dremio or AWS Athena that could run queries on the data in your data lake. But there was still a lot of functionality missing to really make it truly supplant something like a data warehouse until recently, and that's where we end up with the data lakehouse paradigm, where basically you still have storage, you still have processing, but now we introduce those missing pieces. Okay, the table format that allows us to track groups of data as individual tables, and catalogs allow us to track many tables. Okay, so when we say catalog versioning, we're talking about being able to capture different versions of the versions of tables you have within your catalog. So you're versioning the catalog, not the individual table. And this is all part of a grander trend called data as code, because basically you're treating your data like you treat code with Git, also under the umbrella of data ops, where you're trying to automate a lot of data quality processes so that way you maintain data quality but also remain very productive. And generally when we talk about versioning, it all revolves around the idea of a commit. A commit is essentially a point in time, and basically as whatever changes, so as code changes in the code world or as data changes in the data world, each time it changes, we capture a commit, a snapshot of those changes. Okay, and the great thing about that is that we can now retrace the footsteps of the life of that data. And we generally are able to tag commit. So we can say, hey, this commit has this name, so we can easily replicate the data at that point in time. But on top of that, we can also create a branch where we can say, hey, you know what? We're going to have certain changes that we want to isolate. We want these changes to be separate from our main view of the code or the main view of the data. And we can just do those changes on a branch that essentially operates like a copy without necessarily copying the data. And if we like those changes and are happy with those changes, we can always merge them back in to basically get the final result. Okay, and so it's these types of functionalities that basically bring us to the data as code, data ops world. We're trying to bring that over from Git and code into data. And generally we'll do this. We'll get several benefits from doing this, such as isolation, being able to isolate the work on that data separately. being able to make essentially copies of the data without making copies, being able to operate on multiple tables and publish those changes simultaneously, being able to roll back your catalog across several tables simultaneously, being able to reproduce the state of multiple tables through tagging simultaneously. Okay, and again, this is specifically the catalog versioning, but anytime you're versioning, anytime you have commits, these are the benefits you get from having that versioning capability. And again, a big benefit of that is being able to have the space to validate the work. Now, Nessie is a catalog, so it means it tracks the tables that exist in your data lake, so specifically Apache Iceberg tables. So Apache Iceberg is the table format. That's how we know that this group of files is a table, and then Nessie will track all the different tables. But Nessie captures its own commit history. So basically, Nessie is a list of different tables and sort of where they at in their history. So every time one of those tables changes, basically Nessie is going to have a commit that gives you a new snapshot of, say, hey, which snapshot is each individual table at. Okay? So basically you have those commits that you can use to tag, you can use to time travel at the catalog level. But on top of that, Nessie has the ability to branch. So you can create a branch and start changing tables within your catalog on the branch. You can make multiple changes to multiple tables and then merge them in, okay? Just like you could with code with Git, okay? And then you can tag certain commits to make them very replicatable. Now, the benefits of this whole approach with Nessie, okay, is that you get these abstractions at the catalog level, because there's other ways to do versioning. There's file level versioning, there's table level versioning, but table level versioning really only lets you kind of keep track of one table at a time. While file level versioning is kind of doesn't really lend itself to really strong use of SQL, so that way you can have a much easier form of usage. But here you get all of the above. Okay, it's open source, so Nessie is an open source project, but you can get a managed service. Dremio offers a managed service as part of a managed Nessie catalog. It's Dremio's Lakehouse catalog that's part of its Dremio cloud service. Totally integrated, so you don't even have to really think about using it. It's just there. Okay, it's cloud agnostic, so you can use Nessie with any cloud that you want. It's storage agnostic. You can store the data anywhere you want. You're only limited by the tools who connect to the catalog, not by the catalog itself. And basically, Nessie has its own set of tools to help do table cleanup, so that way you can clean up your data sets across multiple branches with its GC cleaner. And when you're using Dremio Cloud, Dremio also has automated table optimization services attached to that catalog, giving you all sorts of really cool benefits. Now, if you really want to kind of get hands-on and see what it's like to use Nessie, what I recommend is scanning this QR code on the left, which will take you through an exercise where you'll set up an environment, a Lakehouse environment on your laptop, see how easy it is to work with, and see Nessie in action. Okay? And if you want to kind of try it using the cloud managed version of Nessie with Dremio Cloud, you can scan the QR code on the right. Okay? And here are some other tutorials where you can try an end-to-end Lakehouse exercise, where you'll start with a data source, which could be MongoDB, Postgres, or SQL Server. Ingest that data into your data lakehouse, okay, using Nessie, using Apache Iceberg, using Dremio, and then actually serve a BI dashboard using Apache Superset. And you can do this all from the confines of your laptop. Okay, so you can choose your own adventure. Again, if you took a picture of the slides in the beginning, then you'll have all these QR codes at your disposal. But just one last reminder to register for the Subsurface Conference. That's going to be on May 2nd and 3rd, and you can register for that here by scanning this QR code. You will receive a copy that is the final print version or release version of Apache Iceberg Definitive Guide for registering for Subsurface, so don't miss it. Okay, but with that, that's the end of our presentation, and basically make sure to check out all this stuff, and I'll see you all later. Have a great day and enjoy, and check out the links in the video description, and I'll see you all later.